Okay, we're ready.
You go first.
Okay. Hello, everyone. Hello, Dr. Phillips. We were tasked in ECE3710, or microcontrollers, to build a project with multiple inputs and multiple outputs. And we got to thinking one day, what are we gonna build? What do we want to do? So Daniel has some thoughts on that.
Well, I remembered Christmas time as a child. Just about every year between the ages of like 4 and ever since then, even now, I have always wanted the same thing for Christmas every year: a remote control car. I love them so freaking much. I remember my birthday when I was 8, I got a remote control FJ Cruiser, and I had to wait like an hour for the battery to charge so I could drive it for 30 minutes just to have to wait another hour for it to charge. It seemed like I just could never have as much time with the remote control car as I wanted. But when we were tasked with this project, I got to thinking of what we could possibly do, and like many of my thoughts came to a remote control car. I was like, that wouldn't be too bad. Grab a couple radios, grab the 2 microcontrollers that we already have, piece them all together with lots of wire, and boom, we would have a toy that could provide endless entertainment created by ourselves from the ground up. We got really excited about this idea.
So we decided to make an RC car from scratch. Now, however, we know a car needs the requirements. An RC car needs the following requirements. It has to steer, it has to go backwards, because sometimes we run into walls, and it has to be wireless.
Mm-hmm. We carefully picked out components to meet all of these requirements. We had a 12-volt motor to go forwards and backwards. We used a stepper motor to turn left and right. We needed driver circuits for both of those motors, radios for the wireless communication, and a battery because we did not want to have to plug our remote control car into a wall and have a leash on it, so to speak.
All right, let's get to work.
First, we made the schematic design, and this included some buttons, which had left, right, backwards, and forwards controls, and a voltage divider, which could take the battery voltage at 12 volts and divide it up into 5 volts and 12 volts, so we could use it for different components. It also had a microcontroller, and this microcontroller, with all its GPIOs, controlled and was the brains of the circuit. The H-bridge and the motor driver controlled the main motor, the forwards and backwards motion, and the stepper motor controlled the left and right motion of the car. We then went online to order our parts. We got a motor, an H-bridge, a battery, and a battery charger. And while our parts were arriving, we decided to start the design of our car. The design of our car included steering, so that it could go left and right, a microcontroller bed where the microcontroller could rest while the car was moving, a battery bed while the battery could rest while the car was moving, and a motor so that the motor didn't fly out when you turned it on. Our car also included wheels and an axle, where the axle had to be sanded down because I made it a little too big, a drive belt cut out where the motor could attach to the axle and actually drive the car. And the steering worked by pushing that top piece left or right, and it would make the wheels move left or right like a car does. I sent the designs over to my friend who has a 3D printer, and he began to 3D print the body and the parts of the car. And since our car was so cool, he couldn't resist himself and he started to build it. But we're going to do that later. While we were coding the wireless transmitters, we realized it was made for an Arduino board and wouldn't work for our STM board. So instead, we decided to make a car with a leash, which isn't ideal, but we had to make it work. We started coding again, and we eventually finished the coding and started work on designing the circuit. We got the motor to go forwards and backwards when we pressed the motor, and we finished the circuit later. By then, our parts had arrived and we could start the building process. I first started with the wheels. We had to add some rubber bands so that the wheels didn't slide every time it tried to move. We then added in the axle and the rest of the wheels. Then we put together the steering mechanism. It consisted of 2 bars on top of another bar, which then could control the steering, and our car was complete. Then I added in the microcontroller. I first started with the back and got the motor to work. Once I got that working, I attached it in permanently so that it wouldn't fly out when we started driving. Bam, our back was done. We got to work on the steering part, which became a little tricky because we didn't design it in the best way for the steering, but we attached this belt on there so that the stepper motor, when it turned, it could turn the wheels either left or right. After the stepper motor driver was attached to the car was complete. We got to work soldering together the H-bridge and the voltage divider on this board with the world's worst soldering iron. After some grueling hours of using this terrible soldering iron, we attached the H-bridge and the voltage divider to the rest of the car. Then, the worst happened. Our car, it blew up. The magic smoke and everything. A flame literally burned a hole through our H-bridge, and since we didn't have enough time to order another part, our project wouldn't work. We tried to take some footage of it working, but eventually we just had to throw the H-bridge circuit in the trash. However, we wanted to mention another project. There was an ECE ornament competition, and my friend said, "Would you be interested in making some?" I said, "I'm down," and so we got to work. We got a small group of friends together and started working on these PCBs. We designed the PCB, and then we had them shipped to us, and look how beautiful they were. We soldered all the LEDs on them, and we coded them so that each board had a unique set of lights and different functions that they could work with. We also made them so you could string a bunch of them together and have an entire tree filled with ornaments.
Although we didn't get to drive a remote control car this Christmas, we haven't given up yet, and we want to finish it later.
There are a couple of things that we could do different with our design to help us out. We need a new H-bridge, and we need to pick different radios that are easier to integrate with the STM32 interface. And with those 2 things, this thing will be up and going in no time.
And we did win a competition with our ornaments, and we won the award.